Our team was hired by a small car dealership in order to create a website and database they could use to track orders and their inventory of small to mid-size sedans. We created a vehicle tracking system in order to help process requests and keep track of the inventory and orders. We created an object-oriented system of modules to help keep track of cars, sold vehicles, back orders, sales, and the customers shown as objects, with details about each being stored as data members of the objects. We then also created an SQL-based database server for holding all of our data within one area, and created a website around the database. This allowed users, such as the dealership employees, to easily submit and change any info about vehicles or orders in the database based on the current position of said orders, such as whether or not it was fulfilled, if it was on back order, what kind of car it is, and other information. There were some challenges that arise when designing and implementing a software system. One of the main challenges is usability. When designing a system, the end goal is to create something that is not only understandable by the developers, but also easy to use from the standpoint of the user. The user does not inherently know how to use the software system like the developers do, so ease of usability, especially for commercial products, is a main priority. Another priority is the maintainability of the software system. Not only should the code be written in a way that is easy to understand and follow for the developers that are creating the system, but the code and respective documentation needs to be able to be read and understood by the maintenance team. The maintenance team needs to be able to understand the inner workings of the code in order to fix any issues that arise during day-to-day use, either by the users encountering an error or the testers finding a fault that was not accounted for in the initial testing. This can only be accomplished by having easy-to-read code and proper documentation, with the lack of either making the task more difficult and the lack of both potentially making the task near impossible.
The problem boundary stage of development began as soon as the team was created. Each person in the group introduced themselves and spoke on their strengths, weaknesses, and preferences, so we could all plan for future role distributions. We also decided on the type of management we wanted, which was an egoless, democratic type, where all individuals had an equal say on decisions. Due to this, each role was assigned through volunteers. To ensure accountability, each person had to document their contributions to the product in regular time intervals. Prior to role assignment, the team performed an overview of the project, discussing potential and mandatory requirements and deliverables. The group also created a project schedule to estimate the amount of time each activity would take, as seen on the slide. With all of this in mind, the team was ready to move forward.
Now that we have analyzed the project description for a vehicle tracking system and set its limitations, we decided that the project must be able to run on a local web page with functionality to keep track of orders and inventory of small and mid-sized sedans. To achieve this, we set the following requirements to satisfy the corresponding system: the customer and also the dealership. A database must be linked and implemented, allowing queries relating to information about a vehicle, including its make, model, transmission, VIN, color, and year. Users must be able to search for cars in the inventory, add and delete vehicles, process customer orders, and allow a search functionality of back-ordered vehicles. To do this, we will have a login and register page for administration where customers and vehicles can be added and analyzed appropriately. This will all be implemented in a web-based interface with clear descriptions on functionality for both the dealership and customers. After the requirements are set, our group investigated how to meet these requirements by decomposing the system into smaller modules. We utilized an object-oriented decomposition, as it was clear to us how to represent the necessary components as objects and information and functionality each module must achieve. The submodules are as follows: vehicles, back-ordered vehicles, sold vehicles, customers, and sales. Each of these modules contains data that can be obtained and manipulated. Our system follows a 3-tier architecture in which the first level is the presentation tier, consisting of a web-based user interface. The second level is the application and server, in which we utilize Flask for the logic of the application with an extension of SQL Alchemy that allowed us to directly provide the functionalities of SQL. The final level is the database server, in which SQLite stores all data in a single file.
Program design was one of the first things we did as a group. We needed to work on the design of our project before we can actually start working on the code. We as a group decided that we will use Python, CSS, Flask for the web framework, and SQLite as a relational database management system. The three major functions that we needed to sort out were getting, adding, and deletion of the various posts regarding the cars that user might look to. So we decided to use an ordered map that will store all the posts with help of unique keys given to each post on creation. We also wanted to use a simple design to allow users to easily navigate through the website. The UI will be set up with a home page to greet the user, and also on the home page we will allow user to choose or log in or register to an account. Another idea that we came up with as a group was that homepage will show various options to user and give options to the user to what he can choose from and what he or she wants to do inside the website. This basic layout we created, we knew it's going to help us while coding of the website, as now we had a clear idea in our mind what we needed to do. So the next phase that we had to move on was coding. After doing system designing, our team moved on towards program design, as this was one of the first things we did as a team. We needed to work on the design part of our project before we can actually start coding it, so that we had a clear vision and a clear goal in what we needed to accomplish while doing the code. We as a group decided that we were going to use Python, CSS, Flask for the web framework, and SQLite as the relational database management system. The three major functions that we needed to put inside our project was getting, adding, and deletion of the various posts that a user might look to or create. So we decided to use an ordered map that will store all of our posts with unique key given to each post on the creation. We had this idea basically set up in our head. We wanted a simple design for our user to actually navigate through the website. So the user interface that we were going to set up was going to have a homepage to greet the user, and there was going to be a login or register account option for each and every user. We also decided that homepage will show user and various options available throughout the website, so that he or she can navigate through the website easily and easily find what he or she is looking for.
Thanks to great planning, the coding portion of the process went smoothly. The team used Python, HTML, CSS, Flask for the web framework, and SQLite as the relational database management system to build the website. When coding the site, coding standards and styles discussed by the group were used. The chosen languages, frameworks, and database management system made the program easy to read, so large header comment blocks were not necessary. Instead, the team opted to use simpler header comment blocks with the name of the individual who worked on each class or function, the purpose of the class or function, and, if applicable, the purpose of each argument. Other things that added to the readability of the code was Python's emphasis on spacing and the group standard of using meaningful names. Testing was another large part of the code and debugging process, and will be discussed next.
Once the code was completed, we began testing the form fields to make sure that each section that allowed input was able to accept data and send it to where it needed to go. Examples of input form fields that were tested are user creation and viewing vehicle data. We tested different kinds of input until we were satisfied with how it was handling the data. The different types of input helped smooth out the bugs we would come across. Once we were done with the unit testing, we proceeded to test the entire software. We chose to do bottom-up integration for the integration testing. We tested lower level parts first and then the higher level parts. We tested each section of the code to see if it was functioning properly without issue. We would enter data regarding the vehicles to see if the database was functioning correctly. With each test, we were able to check off a section of the code, which then added together, and we were checking off larger sections of the code. With this approach, we were able to verify that our software was working as we wanted.
Because of the great teamwork that our team did as part of a unit, the unit testing part of the app went very smoothly. We knew system designing was going to be one of the most essential part of the app and one of the most hardest, so we worked towards it with utmost dedication. We performed system testing on a complete integrated system to evaluate the system's compliance with its specific requirements. We tested the functionalities of our system from end-to-end perspective. Here we did the system testing for stress and performance. We as developers also tested the application by repeatedly giving it improper inputs and stress testing it. We also shared our application with a bunch of random people to get their output and so that we can stress test it while they are using it. We noticed that there were some problems with the speed of the database, so we made changes specific to our requirements. We also noticed that there were errors in the log messages being sent to the database, and we found a few errors in our code that we had to correct regarding those. So we did the whole process again till we were able to get rid of all of these kinds of errors as best to our knowledge.
Once the deadline for the project to be released hit, the team celebrated by demonstrating the project live virtually to a class of computer science and computer engineering majors at the University of South Florida. The presentation was virtual, since this was completed during the COVID-19 pandemic. The team made sure to be open to any questions or concerns if anyone wished to approach them after the demonstration, so that they could keep them in mind for the future. Prior to the demonstration to the students, the group also presented the project to others close to them for suggestions on improvements. Another important part about system delivery is whether or not people are going to know how to use the product and install it into their system. A readme.md file was created describing how to install the system into one's own local computer. Documentation within the code itself, error messages, and the README are all helpful tools that were implemented into the project to ensure future developers and operators understand the functionality behind the code. The demonstration portion of this video was also created to help make sure users have a way to learn how to use the software.
After the launch and successful execution of our website, our team was extremely happy and joyful. But we knew that there was only one way that we were going to be able to continue our success and we'll be able to get through the continuous, and that will be through the continuous maintenance of our website and our database. We knew our site will have a vast database, so it will require constant amount of maintenance. There will be car posts which will be either wrong or inappropriate for the public to view, so they would have to be constantly monitored and taken down if they were inappropriate. We also knew we were going to need to perform corrective maintenance to take care of day-to-day bugs and fix those. We also knew we had to take care of the adaptive maintenance to keep up with the changes in the environment of our app and changes in the modern day operating systems. Although we don't have to work on the adaptive maintenance part just yet because our app was only launched a few days ago, but still we are keeping it in mind for the future perspective. We also know that the preventative maintenance will have to be performed annually, which will give us the opportunity to make our systems better. While coding the app, preventive maintenance was already taken into consideration as we were trying to develop a great product in the first place, which has a lot of redundancies and modifications to prevent bugs and system inefficiencies. So if there is any kind of exception that may arise, that can be taken care of. But rather saying that, we will still have to continue doing preventive maintenance in our future coding while maintaining our app.
Now that we have analyzed the project description for a vehicle tracking system and set its limitations, we decided that the project must be able to run on a local web page with functionality to keep track of orders and inventory of small and mid-sized sedans. To achieve this, we set the following requirements to satisfy the corresponding system: the customer and also the dealership. A database must be linked and implemented, allowing queries relating to information about a vehicle, including its make, model, transmission, VIN, color, and year. Users must be able to search for cars in the inventory, add and delete vehicles, process customer orders, and allow a search functionality of back-ordered vehicles. To do this, we will have a login and register page for administration where customers and vehicles can be added and analyzed appropriately. This will all be implemented in a web-based interface with clear descriptions on functionality for both the dealership and customers.
Hello, our group, Team Tyler, decided for our project we would create an enterprise vehicle inventory system, the likes of which a dealership would typically use to manage their inventory system and customers. Our company and product name is RoadQuery. And as a quick summary of how the project works, we used Python to build the website with the Python module known as Flask. We also used a backend database system built with Python module SQLite, which operates based on SQL code. And the backend of the database is where all of the vehicle and customer information that is stored for use between times the program is run. To connect to the website front end and the back end together, we use another Python module known as SQL Alchemy. And we used some basic HTML and CSS code to style the website as well and give it a user-friendly and intuitive experience. When you visit our About page on the website, you can view a small description of the project and the group members involved in Team Tyler, each one of us playing an important role in the development and documentation of RoadQuery. RoadQuery has a functional login system that allows customers to create accounts and log into the system, which could be used for user privilege levels and other things of that matter. We can see that the login and register system also works as it should, not allowing users to log in that haven't registered. So we could see that here. And you can see the login was unsuccessful. So if we can either navigate to the register page through this button down here or register up at the top. And we will see all of the information that we have to fill out in order to register. And I'll input all that same information that I did when trying to sign in. And you can see now the account was created. So if we come back to login, and now we can log in, and you can see at the top that you have been successfully logged in. We also, on our main page, we have several options that allow users to view vehicles in inventory. The first of which being an option that shows all vehicles in every inventory. So when you click that, you get a list of all the vehicles that are in stock in inventory, separated here by the vehicles that are on back order, and then very last, the vehicles that have been sold. We also have a option that allows you to search vehicles in inventory by make, model, transmission, VIN, color, or year. We'll try, for this example, a search by make. And we will search Subaru, and it appears all the vehicles at the bottom now of the make Subaru that are in inventory. And we'll go back. We may also add a vehicle to inventory fill out the information, and then click Add Car. And that adds it to the database. You can see up top. So when we come back to all vehicles in every inventory, you can see now this vehicle is added here, as well as coming back to search vehicles. You can see now it displays here as well. The same exists for backorder inventory, where you can search by make, model, transmission, or year. So if we wanted to search all of the automatic vehicles that are on backorder, it'll display them here. Same with manual. The same for the sold vehicles. You could search by make, model, transmission, VIN, color, or year. So if we wanted to search for vehicles of the year 2020 that were sold, they would appear here. And you can also see if you search for an option that does not exist, you will get nothing. So say now we want to delete that car that we added earlier. You would go to delete vehicle from inventory, and then it asks you for the VIN of the vehicle, since this is the unique identifier, so you want to make sure that you are entering or deleting the correct vehicle. And we typed that VIN in as test before, so we'll go ahead that. And then you click the button and it should be deleted. So coming back to all vehicles in every inventory, you will see it no longer appears at the bottom of here. And when we come back to search vehicles, search by make, like we did before, it no longer appears here like it did before as well. Next we have our list of customers, or our customers options. You can view the list of all registered customers, add a customer, and search through registered customers. First we'll show a list of all registered customers. You could search registered customers by first name, last name, age, or their customer ID. And you'll see it'll display here. And then say we wanted to add a customer, you would come into this page and fill out all the information. Click add customer. And you can see there's validation as well. And then the customer is added to the database. So when we come back to our list of registered customers, you can see he is now at the bottom. And you can come back to search customers, search by their name, and see they appear here as well. And that covers everything for our website. Thank you.